All right, this is the podcast for dividing monomials. This is the third section in the exponents chapter. So if you remember, when we are multiplying variables with exponents, the rule is we add exponents. Unless we're doing powers, then we multiply. So now just the opposite with dividing. When we're dividing with exponents, we're actually subtracting. So looking at what's called the quotient rule now, for the quotient rule, when we have x to the a power divided by x to the b power, we have the same base of x. We would actually subtract our exponents. So I have x to the a minus b. So we're subtracting those exponents. So for example, number 1, x to the 5th over x to the 3rd. Now, I always take the small exponent to the large. So I'm going to take that 3 up to the top of my fraction. So it becomes x to the 5th minus 3. 5 minus 3 is 2. So x squared. Okay, number 2, I have k to the 12th over top of k squared. So I take that small exponent to the large and I subtract. So it is 12 minus 2 in the numerator, so k to the 10th power. Number 3, you'll notice it is m cubed over m cubed. Anything over itself is just 1. So it could be 5 over 5, 10 over 10, x over x. Anything over itself equals 1. However, if we use the rule, take the exponent and subtract it, I would have m to the 0 power, because 3 minus 3 is 0. Anything to the 0 power is 1. That's just a general rule with exponents. It could be x to the 0 power, that's 1. It could be 5 to the 0 power, that equals 1. So the rule is anything to the 0 power equals 1. Okay, so looking at example 4. Now I have multiple variables. Okay, so with multiple variables, I split the variables apart and I do them separately. So starting with the a's, I have a to the 6th power in the numerator and a squared in the denominator. So I'm going to take that 2 up and subtract. So in the numerator, I have a to the 4th power. With my b's, I have b to the 4th power in the numerator, b cubed in the denominator. So that is 4 minus 3 in the numerator, which is b to the 1st power. So this one happened to work out that I don't have anything left in the denominator. So we can just call that our answer. Okay, so go ahead and try number 5. And 6. Okay. All right, I'm going to scroll down, and now when we add coefficients in the mix, okay, it's just like with multiplication, you're going to do those coefficients first. So I'm going to create my little line here, equals. So we start off with 6 divided by 2. 6 divided by 2 is 3. And then I have x to the 4th in the numerator, x cubed in the denominator. I'm going to take that up. 4 minus 3 is 1, so x to the 1st power. Number 8, 14 over 7. 14 divided by 7 is 2. Then I go to my r's. I have r squared in the numerator and divided by r in the denominator. So bring that 1. This is r to the 1st in the denominator. Bring it up. And subtract 2 minus 1 is r to the 1st, which you don't need an exponent, but you can have it there. S is s squared over s. 2 minus 1 is s to the 1st power. So 2rs is our final answer here. Okay, number 9. Negative 36 divided by 4 is negative 9. I have c squared over c squared. So remember, when it's the same variable to the same exponent, it just equals 1. So I'm just going to cancel it out. Now to my d's, d to the 5th in the numerator, d cubed in the denominator, bring it up and subtract. So I have d squared. Okay. All right, go ahead and try number 10. Number 11 I'm going to do real quick. With number 11, 4 over 8. 4 over 8 simplifies down to 1/2. So in this case, you actually have a denominator, which is that 2. N to the 5th in the numerator, n to the 1st in the denominator. Bring that up and subtract 5 minus 1. So I have n to the, oopsies, the 4th in the numerator. Okay, so I can rewrite that n to the 4th over 2 would be how to simplify that. Or 1/2 n to the 4th, it means the same thing. Okay, so go ahead and try number 12 as well. So you have 4 problems to try on your own. I will check them tomorrow.